This corresponds to section 8.6, solving rational equations, and you must, when you solve these, you have to check for extraneous solutions. So that's kind of one of the good reasons that both rational and radical functions are in our unit together. Because with both of those function families, you have to check for extraneous solutions. So be sure to do that here. So we're just going to solve, and we'll do 6 examples. So the first one is 3 over 5x. And you've done some of these sort of at the Algebra 1 level, the basic ones. 2 over x minus 7. So something like that. We're just solving for x here. But what values would not work? Look at the denominators. Just tell me ahead of time. If we were to get these answers, what would we not include? Look here. 0 and 7. Do you see that if that happened to come up when we solve these equations, we would cross them off. Otherwise we would be wrong, because you can't plug those numbers in here. It won't work. You can't divide by 0. Okay. So the strategy here, because you have two fractions equal to each other, we're going to use something called cross multiply, because that's the easiest way to do these. We'll simply cross multiply. When you have a fraction equal to a fraction, you simply multiply this way and this way. So 2 times 5x is 10x, and 3 times this, be sure that you distribute the 3 to both. So since there's 2 terms here, I would put it in parentheses to be sure that you distribute. So you multiply, it's called cross multiply because you multiply across this way and then you multiply across that way. And the reason that's mathematically okay is what you're doing is you're getting rid of the denominator. You're multiplying both sides by 5x, and then you're multiplying both sides by x minus 7. But you're just saving time. You're doing it all at once. But it's mathematically correct. So then, now we're at Algebra 1 level. We distribute the 3. We combine like terms. I'm going to subtract 3x from each side. And I'm going to divide by 7. So x equals -3. And that is the answer. It was not one of the solutions that can't be. So -3 works. Let's try this. Number 2. 1 over 2x plus 5 equals x over 11x plus 8. Again, we're going to cross multiply. So you still have an equation, of course. Multiply this way, x times 2x plus 5. This way is 11x plus 8. And now we just have a linear equation that we can solve. So you distribute 2x squared plus 5x equals 11x plus 8. Oh, now what kind of equation is this? It's a good review. It's not linear, it's quadratic, because we have an x squared, so we could potentially get 2 answers, and this is a good review. So you get everything equal to 0 and factor. You're going to see this over and over again. So 2x squared, I'm going to leave this on the left side. I'm going to bring 11x over, so subtract 11x, it's minus 6x. Subtract 8 equals 0. Get it all to the left. I want to keep the leading coefficient positive because that makes it easier to factor. So I have to factor this. I have to write this as 2 things multiplied together equals 0 so I can solve. So let me review the process. You can do diamonds and rectangles. You multiply the first and last. What do you put on top? Multiply that and that. Good, -16x squared. On the bottom goes the middle. So what 2 numbers multiply to -16 and add to -6? -16x and 10x. Does that work? No? They oh, no, that doesn't work at all. So what is it? Good. 8x and -2x. I think we need to switch the signs. Okay? Yes? Happy? Yes? And you have to do the rectangle because the leading coefficient is not 1. So here's how you do the rectangle. First term goes in the first box. Last term goes in the last. Yeah.
Would it be easier just
Ah, good point. The numbers would be smaller if you factored out the 2. I'm going to finish it like this, but yes, that's great. If you factor out the GCF first, then you could do it a different way, and that's great. Very good. So the last term in the last box, and then negative 8x and 2x. So going around the outside, that works, and that works, and that works. So it's 2x minus 8 times x plus 1. And let me show you that if you had factored out the 2 initially, this is what you would get. But your answers, this is a nice learning point here, your answers are going to be the same either way. So you get 4 or negative 1, but you have to make sure that they don't make the denominator 0. And they're okay. They don't make the denominator 0. So both of these work. So 4 and negative 1 are your solutions. I'm going to go to the next board for number. Now they're going to look different. So notice the pattern. Are there any questions there? When you have a fraction equals a fraction, you cross multiply. So now let's try this. Let's try this. If this looks, tell me why this is different. Because students try to cross multiply and you can't. I'm going to solve this rational equation now. It's rational because x is in the denominator. Why can I not cross multiply? Yeah, you have 2 terms over here that you're adding together equals that. So cross multiplying will not work. So what you do on these is you fraction bust. Okay? And that means multiply by the lowest common denominator and all your fractions will disappear. That is the easiest way to do these types of problems by far. That is the best trick, is get rid of those fractions so you don't have to deal with it. So the lowest common denominator is what you would use if you were trying to like add these 2 fractions together. What would it be? 2 is part of it. The lowest common denominator is 2x. It includes a little bit of both. If you wanted to add these together, you would have to get a common denominator of 2x. So that will get rid of everything. So watch what happens. Take this equation and multiply everything by 2x. Just distribute 2x. You're being fair. As long as you do the same thing to everyone, you're being fair. That's just multiplying both sides by 2x. And now watch. All your fractions get canceled. The 2's go away here, so no more fraction. The x's cancel there, no more fraction. And what's left over is a very nice equation. 7x. Here it's just plus 6 equals 6x. LCD means lowest common denominator. It's like the common denominator, basically. Usually what you hear it as common denominator. This is the result. So the hardest work is done. You just solve it. From there you get everything on the same side. So you get x equals, move this negative 6. That would be the answer if it works, and it does because it doesn't make the denominator 0. So I'm going to do another example. 3 over 7 plus 8 over x equals 1. So what's the lowest common denominator? 7x, yep. If you just multiply everything times 7x, like this, times 7x, times 7x, multiply all the numerators by 7x on the top, watch, all your fractions will go away. The 7 on the bottom cancels with the 7 on the top, the x cancels with the x, and there's nothing that cancels here. So what's left over is just 3x. What's left over here? 56 equals 7x. Oh, so easy to solve that. That's just a linear equation. Get all the x's on the same side, subtract 3x from each side, and divide by 4, and you get x equals 14. 14 is not a problem. 0 would be a problem here. X can't be 0, but 14 is fine. And I think we'll do one more example. And then you have to try it. So they don't get much harder than that. I mean, they can get harder than this, but we're not going to do any harder than this. 5x over x minus 2 equals 7 plus 10 over x minus 2. I like to leave space when I'm writing the original equation because I know I'm going to be multiplying everything by something. So the lowest common denominator, x minus 2. If I wanted to add these fractions together, I would have to get everything over x minus 2. That's the hard way to do it. Don't do that. So you multiply everything by the LCD. So watch, it'll be so much nicer. Oops, I'll put it in purple. So you multiply this, this will be our last example. You multiply this by x minus 2. You multiply this. Make sure you hit everything. You have to multiply every, because of the distributive property. So this goes away entirely. This goes away entirely. And you're left with 5x equals 7 times x minus 2 plus 10. And that is very solvable. Nice and easy. So you do the distributive property, 7x minus 14 plus 10. You always combine like terms when they're on the same side, if you can. So negative 14 plus 10 is negative 4. Get all the x's together. I'm going to subtract 5x from each side, and I'm going to add 4, and then I get x equals 2. What is the problem with x equals 2, Soham? It doesn't work. 2 would make the denominator 0, so you have to say, you have to cross that off, and you would say there is no solution to this. Because that's an extraneous solution. It doesn't work. You have to double check. Whenever you're solving rational equations, you have to look at the denominators and make sure that you're not making something 0. Because if you these two sides, no solution means that these two sides will never equal each other no matter what you plug in for x. You can never get the left side to equal the right side. So therefore there's no solution to that equation.